We are taking a question and answer on 8085 microprocessor. Explain briefly the flag register in the 8085 microprocessor. So the flag register, these are basically flags. So these flags represent after certain operation, what has happened, what is the state, what are the changes. So this flag register tells you about the status or situation. So let us take one by one flag. First, let me tell you the flag register is in 8085 is an 8-bit register, and it contains, this all flag contains 5-bit position, that is 3 we are not taking, but in all 8 it can be set 1 or it can be reset, that is 0. So these 5 flags are 1 bit when they are set, otherwise they are reset. Okay, so this 1 means that this particular flag is set. 0 means this is reset. Okay, so let me tell you about one by one, D0 to D7. D0, so this flag D0 is a carry flag, and this gets set when there is a carry generated by an operation. If we do some add or some subtraction and we need to carry certain thing, so this will be set, otherwise reset. D0. So we are not talking about D1 and D3 and D5. We are talking about D0, D2, D4, D6 and D7. So these 3, 8 minus 3, this, so 5 are being used. Okay. D2, parity flag. So when we have even number of ones, this parity flag is set. That is, if we have 1, 1 or 3, 1 or 5, 1, it will be reset. Even number of ones only, then this parity flag will be set. Like 2 ones, 4 ones or 6 ones, like that. Right? Now coming to the auxiliary carry flag. Auxiliary carry flag. Now this auxiliary carry flag is set when there is a carry out of lower nibble. Nibble means, since see we have 8 bits, so the lower part or the 4, 8 consists of 4 and 4. So the lower nibble or lower 4 bits of the operation, when there is a carry out, then we say it is auxiliary carry flag. This is used for BCD operation, not very much free to the programmer. This is auxiliary carry flag. Now coming to 0 flag. This is D6. So this, when you have done certain operation and the result comes as 0, 0, 0, 0, 0, 0, 0, 0, that is, when the result of the operation is 0, then it will be set. Then sign flag. Sign flag, for example, this is a bit sequence. This is 1. That means this sign flag will get set when the result of an operation is negative. Right? Okay. List out the function of accumulator. So before I can tell you about accumulator, let's go ahead and see here the architecture of 8085 microprocessor, where the accumulator actually lies. So we will talk about the registers like BCD, HL, stack pointer and the program counter, etc. But here we have accumulator. Why it becomes so important? Because accumulator, this is a 8-bit register first of all in 8085. So register is nothing but the combination of flip-flop. So a flip-flop means 1 register. So this is a part of ALU, arithmetic logic unit. This is the important part. So this particular register is used to store 8-bit data and also to perform the arithmetic and logical operations. The arithmetic and logical operations. So the result of the operation is stored where? In accumulator. So we identify it using register A. So accumulator holds one of the data or the data which is processed by LU, and also it stores the result of the operation. So it's a operation holding area. So it also works as a VIA, that is the route register for input output accesses. What does it mean? It reads data from the input device and it transfers the data to the output device. This is your accumulator. What is program counter? So we also call it as PC in 8085. So let me tell you about this whole situation here. We have certain register B, C, D, E, H, L. These are general purpose register. We have flag register, we have accumulator A. Now in order to handle all these, or in order to handle the data, we have certain say supporting program counter or stack counter like this. These are also the register. So they are special purpose register. So program counter is a 16-bit special purpose register. So when we have a program, this special purpose register of 16-bit program counter, while we are working on certain say this instruction, the address of the next instruction is held by program counter, or you can say this program counter hold the memory address of the next instruction to be executed. What is a stack point register? Describe briefly. See, stack, we'll talk about stack in a while, but the stack is a memory, that is, it is an area in random access memory which is given for certain temporary storage of data. So when we implement a stack, it is in the RAM, random access memory. This is how it is, logically seen. So stack is data one over another. So the last input data will be the first to be output data, last in, first out. This is called stack. So this SP, what you see here, this is a 16-bit register. This is used to point, or it indicates the stack. So in read-write memory, that is the RAM, the location at which the temporary data and return addresses are stored. So this is known as stack, because we need certain place to have some return addresses to be stored, etc. You can just say that stack, it acts like an auto decrement facility for the system, for the microprocessor. So the initialization of stack top is done with a proper instruction, that is LXI SP. What you see here is there is starting address initialization. So this initialization, this is with certain instruction. So now when this instruction is executed, the stack is being made. So you put the items on the stack one by one. So this is called the push operation. So you can have a push operation, or there can be a pop operation, because what you have put in on a stack, you need to pull it out also. That is called popping, pop out. Okay. So always stack pointer will point to this address, the top of the stack. What is stack and subroutine? Stack is a temporary memory location at the random access memory, RAM, and for say some temporary storage of data or the return addresses, this tag is used, like stack of plates. So the last plates to be put is the first to be taken out. This is a concept. So when we implement, we ask with certain say statement instruction LXI SP like that. So the stack is created, one by one we put the data, and then we take out the data, pull out the data. So pushing, that is populating the stack, and popping is depopulating the stack. The stack, it is the set of memory locations in memory. But subroutine is that you have a main program. Okay. Now there are certain tasks which are to be repeated again and again. So rather than writing that code again and again, we can make a function, or we can in the microprocessor language we call it as subroutine. So this control goes to the subroutine and comes back. So subroutine is the group of instruction. It is written separately from the main program to perform a function that occurs repeatedly in the main program. For example, you are calling add function. Why not to just make a function add? So you have certain instruction, means this is the flow of the program. So this is the flow of program, one instruction, second instruction, like that. But when we come to the subroutine instruction, that is when we call subroutine instruction, that subroutine will be called, and there will be some input that will be given to subroutine. Subroutine will give you some output, and then the flow of the program continues. For example, you give 2 and 3 and you get 5. that file is returned to the program, and the flow continues. So I'll show you a very simple program here, and this program is showing this subroutine of assembly language. So everywhere you see there is a call to delay. There is a subroutine named as delay, and we are calling it. So we are calling it number of times in this program. So this control goes and then it comes back again to the main program. So this all call, delay, call, delay, call, delay. What are these? These are subroutine. Okay. Name 5 different addressing modes. So addressing mode in 8085 and various other processor. Every instruction, every you can say program line of a you can call it as an instruction, has to operate on a data. That is, if you do move MVI, LXI or any DAD, it is working on certain data. There has to be some moving of what? Data. So every instruction is operating on certain data. So the method or the technique or the way of specifying the data to be operated by the instruction is called addressing. That is, the instruction can say, tell, oh, this is the data. In the instruction itself, the data is there. But if the instruction can say, oh, this is the address of the data, or it can say the address of the data. That is, you can say, okay, you're saying something to your friend. You have to come to that corner. This is, you can say, there is my house. Or you can say, come to the corner, ask the fellow there, and he'll tell you my address. So there can be different kind of way the data is being specified. Address of the data. Immediate addressing, direct addressing, register indirect addressing, implied addressing. These are different type of addressing. So these 5 you have to remember, because this is only the way of indicating or specifying the address of the data, because it's all about data in any kind of instruction. Define indirect addressing mode and give an example, and also explain immediate addressing mode. We'll talk about both of these. Everything is happening on data. Every instruction is working on certain data. So when it is talking about data, instruction can tell you directly the data. It can tell you the memory address of the data. It can tell you the memory address which contains the memory address of data. So you can tell your friend, okay, come to that shop. Behind that I have my house. Or you can say, come to that shop, ask the fellow, he'll tell you where to go. So you are actually telling the different kind of data positions. So that is called addressing. So we have 5 different kinds of addressing mode. So in this indirect addressing mode, the instruction specifies the name of the register in which the address of the data is available. The instruction will tell you, indicate you the name of the register. That register in which the address of the data is available. Did you get it? Okay, I'll show you with a diagram here. Okay, so that diagram will tell you what is, because it is not direct, it is indirect. So you're not telling the direct address of the data. You're telling that this will have the address of that data. Okay, let me tell you again, the instruction here, we have an opcode, and here we have a register. This register will have an address, and that address will have the address of the data. Okay. In immediate addressing mode, data will immediately follow the opcode, operation code in program memory. So this is your instruction, this is your opcode. There are 2 parts actually of any instruction. So the operand comes from next byte in a program memory. So let me tell you again, this is immediate addressing mode. It tells you, the name itself tells you, the data will immediately follow the operation code in the program memory. In all these expression, in all these instructions, you see that these are based on immediate addressing mode. What is an interrupt? Just assume that your system is working and your hard drive stopped working. For example, you took that pen drive off from your system. So how will the processor, microprocessor and the other device know that this has happened? So this is known by interrupt. So interrupt is basically a signal which is sent by any external device, you can call it as a peripheral device, to the processor so as to request the processor to give some information or to perform a particular task or a job or a work. So this interrupt, we have the hardware interrupt and we also have the software interrupt. The highest priority in 8085 microprocessor is for trap, because if the trap has come, then the microprocessor has to stop all the activity and cater to it. That is, it is non-maskable. The others are maskable. That is, it can be delayed. So this is the formation, this is the whole interrupt structure of 8085 microprocessor. So we have interrupt enable like this, and we have trap. You can see all these RST 7.5 till INTR. What are the types of instruction for 8085 microprocessor? Microprocessor has to be given certain instruction to work. May it be given by your program or inbuilt by various other devices which are there. So there has to be some instruction. The microprocessor work on certain instruction. There are different types, and they can be classified. That whole instruction set of 8085 can be classified on the basis of function and basis of size. So basis of functionality, basis of workability of what it does, the different instruction can be regarded. For example, the first one is data transfer instruction. If the instruction is MOV, the main task is to transfer the data from one main source to destination. So comes the arithmetic instruction. That is, you want to add. Logical instruction, you want to take the AND or NOT, these complement. These are logical instructions. So you have arithmetic and logical rotate instruction. Then the branch instruction. So whenever we come across any program, you'll see jump not 0, call, then jump, then return. So this is the branch type instructions. Okay, and this jump, this all is the branch instruction. Then comes the, whenever you write a program, there is always a stack. In the random access memory, it is given up space. So for that stack also we have certain instruction or instruction set for that particular thing, like a push, like pop, and then XTHL and SPHL like this. So these are stack based instructions. Then comes the input output instructions. For example, we'll just combine these two, input output and machine control instruction. So input output instruction and machine control instruction like halt and all others like this. So we have input output and machine control instruction. On the basis of size also, we have 1 byte instruction, 2 byte and 3 byte instruction. For example, MOV, this is a 1 byte instruction. But MVI, that is the same data transfer function, is a 2 byte instruction. It totally depends on the operation, opcode and the data. Then we have the 3 byte instructions called call, jump, JMP. These are all 3 byte instructions. What is the difference between opcode and operand? So let me show you diagrammatically first. Any system, any computer, they only understand, because they are binary, they only know 0 and 1. So CPU only understand the 0-1 language, that is called the binary language. So the machine code is the binary format of an instruction that will be executed by CPU. So this instruction has 2 parts. Any instruction will have 2 parts. For example, you have this add and then 45. So this add, what is this hash? I'm just going to tell you, because this opcode, the first part, is by itself telling what kind of addressing mode it is going to use. So there are 5 types of addressing mode. We have direct, implied, indirect, like that. But it is working on what data? That is indicated by operand. So you can divide this machine instruction into 3 parts. The opcode itself says what is the addressing mode and on which data it is going to work. That will be the operand, right? So opcode is the part of the instruction that identifies a specific job, specific operation, specific word. And the operand is a part of that instruction that will represent a value on which the instruction is going to act. So the whole instruction has opcode which will work on operand. Okay. So opcode is going to work on operand because both are the part of instruction. The first part you can say is the opcode, operation code, which is going to operate on the operand. Right? This value after the instruction is going to be the operand. So this is, I'll just give you an example, add. I'll just take an example, add A, B. So add A, comma B, it is itself showing that what you are going to do, what kind of data transfer function you are going to use. Write the operation carried out when 8085 executes DADH instruction. Now opcode, operand, there are different kind of instruction, different types of instruction. So that is one of the example we are taking. So the main DAD is adding the register pair to the HL register. As I discussed that we have the register pair B, C, D, E, HL like this. So here the content of the HL pair will be added to the same content and the result is stored in HL. So we have the B, C, D, E, HL, stack pointer and the program counter, etc. Okay. So this DAD is add register pair to the HL register. So the format is basically you have say some register pair. So this RH, I'm just giving a name. It can be any. It can be any. But it has to be added to HL. Basically H and L are two 8-bit register combined where they are called as 16-bit HL pair. And the result will be saved in the HL pair itself. So this follows the addressing mode called register addressing and it comes under the arithmetic group. Its byte content is 1 byte and the flag it affects is carry flag. So this is an example also here. Give the sequence of operation that takes place during the execution of call instruction. Okay. So what happens when you actually call? When you write a code or there is a program, for example, this is the point where subroutine will be called. You can call it as a function, method, procedure, whichever you want. For example, you have a add subroutine. Now 2 and 3 will go. Subroutine is already written. So it will return 5. So there will be a call to this function add and there will be a return. Okay. There will be a return. So there will be a stack because you have to put all the next instruction because after returning it has to go somewhere. Where will the program control flow come? So you have to tell, okay, when you come back, when the program comes back from the subroutine, the program counter, actually it has to be placed on stack because when the program returns, the content of the program counter will be taken back or popped out of the stack. First it will be pushed, when the call is made and returned, it will be popped. Okay. So first of all, the address of the next instruction, which is actually the program counter of the main program, is saved on the stack, which I just told you. And when you just put it, the content of the stack pointer is decremented by 2, indicating the new stack top because this always goes in negative from below the lower part of the stack or the initial part of the stack pointer. Okay. So then the program jumps to the subroutine, starting address specified by the label. For example, you have, I'll give you an example. See, call 50000H. So first of all, the stack, the program counter has to be placed on the stack because this we will need later. Then we have to load this program counter with the 16-bit address supplied with the call instruction because call 500H. So we'll load this with 16-bit now because the program counter always point to the next instruction which is to be executed. So now we are going to subroutine. So it will point to the subroutine next call. And then when the return will be called, we will take the content from the stack and we'll put it on in the program counter, that is pop PC. This will be done. What is a T state? See, this is all related to the clock frequency. Every microprocessor has some clock frequency. So the machine cycle and instruction cycle, they take multiple clock period. They may take 1, they may take 2 or multiple, So the T state is the portion of an operation which is carried out in one system clock period is called a T state. Okay. Let me tell you that operation is carried out. What part of the operation is done in one system clock which is identified by the system frequency? This is called a T state. Okay. How do you get this clock period? From the frequency. because frequency is 1 by t. So time is 1 by f. So the frequency is already specified. Time you can find out. And in this time, in this one time, what is the portion of operation being carried out? This is called the t state. So here you see, it can be, this is a falling edge, this is a falling edge. So one t state, we can just say that this is some portion of where the operation will be carried out. For example, you have a wave and you call it as this is a part, this is the amplitude frequency, or this is the part which is again repeating. So that is a period. So in order to complete any instruction to work, actually, the fetching and execution of instruction will be done. This is called an instruction cycle. So this instruction cycle can have multiple machine cycle. And machine cycle is actually a basic operation that the processor has to perform. And each machine cycle will take a minimum of 3 to a maximum of 6 processor reference clock cycles. So in this context which we are discussing, a processor clock cycle is known as a T state. T, you can say it is a time. T stands for time, you can say. T state. How many machine cycles and T states are needed to execute STA4200H in 8085 processor? H is for hexadecimal. First, you must know what is STA. What does STA do? STA is actually a mnemonic for store accumulator. ST for store, A for accumulator. And storing the content of the accumulator into the memory, STA is used. So when you have STA4200, that means whatever is in the accumulator, it has to be stored in a location whose memory address is 4200. So this is an 8085 instruction that says to store the accumulator at memory location. So there are different machine cycle as I just indicated. So we have operation fetch, then we have memory read, then we have memory write. All these are the operation. Okay. So when you take this machine cycle, how many machine cycles are there? There are 4 you see on the left one. So 4 machine cycles are there. And if you add them, 4, 3, 3, 3, that is going to be 13. So these are 13 T states. So you can say, in order to execute STA 4200 instruction, 4 machine cycle and 13 T states has to be taken, has to be done. So 4 plus 3 plus 3 plus 3 is basically 9 plus 4, that is 13 T states. When the ready signal of 8085 processor is sampled by processor. So this ready signal, basically the 8085 microprocessor is sampling. Sampling is just meaning checking. So it checks or samples the ready signal at the second T state of every machine cycle. We just talked about T state and machine cycle. So this 8085 microprocessor samples or checks the ready signal at the second T state of every machine cycle. What is the function of SID and SOD pins in 8085? See, 8085 has multiple pins. It has almost 40 pins. So there are different words for different pins. SOD and SID, if you know the full form, you will be able to know what it does. SID is serial input data, serial input data. And SOD is serial output data. So this SID, the arrow is where? It is going inside the microprocessor. So this SID line can be input to the most significant bit of the accumulator. Accumulator is 8-bit register. The most significant bit goes through SID. What is SOD? It is serial output data, and this SOD line, this can be used to output the most significant bit of the accumulator. SOD. So SID, it takes 1 bit input from serial port of 8085. Store the bit at the 8th position, that is the MSB of the accumulator. So these are SID and SOD. Please remember 4th and 5th pin for 8085. Why data bus is bidirectional? Now this has a lot of concept inside it. Data bus, address bus, memory bus. First, let me show you the whole scenario. In any microprocessor or a system, you need to have a control bus, an address bus, and the data bus. So address bus is going to fetch the memory, okay, memory address. But data can go in both the direction. It can be saved, it can be fetched also. So address bus needs to be in one direction, unidirection. But because the microprocessor has to read the data from memory or input device for processing. And after processing, it has to store the data to memory or output device. That is why the data bus has to be bidirectional. Unlike the address bus, which is unidirectional in nature. I hope you got the idea. So this address bus and data bus, let us understand the difference between them. Address bus, basically they are wires, computer bus. So address bus, that is used to specify a physical address in the memory is called the address bus. While the data bus, it is also a computer bus that is used to transmit data among the components. So it has to be bidirectional. That is what I am saying. Address bus is unidirectional and data bus is bidirectional. And the address bus helps to transfer memory addresses of data and the input-output devices. And the data bus, it helps to send and receive data. That is why it is bidirectional, sending and receiving both. Address bus, the width of the address bus will determine the amount of memory a system can address, while the data bus will tell you the width determines the data transferring rate. For example, you have address bus of 16-bit. So 2 to the power 60, that is 64K is the addressing capability, while 8-bit data bus means 8-bit microprocessor. How can signals be classified for the 8085 microprocessor? So the signals of the 8085 microprocessor are based on their functions, and that can be classified into 7 categories. If you see the architecture of 8085 microprocessor, we have the frequency and power signals. Then we have the address and data buses here. Then control bus, interrupt signals, serial input and output signals, because interrupt is for peripheral devices more mainly. Then we have the direct memory signals, as I said, serial input, output, SID, SOD. Then reset signals. Mention the different types of data transfers possible in the 8085. See, there are different types of data transfer that can happen in a microprocessor. For example, you have BC, DE, HL, we have stack pointer, program counter, we have various other places. So the data can be transferred from memory to register, register to memory, memory to input-output device, the accumulator to register, like this. So data transfer is possible between 2 registers. Then also it can go from memory location to the register. So the data transfer can occur between the input-output device and the accumulator. Okay. So what happens in the data transfer? The data is actually not transferred. It is just copied until the previous where the data was there is not overwritten by any other data. This is certain example of different data transfer possibilities or instruction in 8085. MOV, MBI, sometimes your address is given, sometimes data is directly given, sometimes indirect addressing is given. Okay, this is all about this discussion. Thank you so much.